জয়েন করবে তো টক টক করে শুধু জয়েন করবে 3-4 বার। জয়েন করবে সরে যাবে, আবার জয়েন করবে, আবার রিজেক্ট করে দেবে। 3-4 বার জয়েন করবে। জয়েন করো, বারবার জয়েন অল লিভ করে দেবে, যাবে। কেউ জয়েন করো। বারবার জয়েন করবে সরে যাবে, রিজয়েন করবে। কিছুক্ষণ পর পর আবার করবে, জয়েন হবে। ওকে, সো গুড মর্নিং টু good afternoon or good evening to everyone whoever joining from India or outside as well. So as a part of this PMRF TSIP, so this is the third session where I'll take some questions with answers, and if you have any query, please let me know regarding the questions. So this is the very generalized topic, advanced chemical thermodynamics and kinetics. So this is just a first question where you have to calculate the coefficient, diffusion coefficient, and in most of the case you know that this is the J is the term where J basically tells you about the concept called this 1.27 into 10 to the minus 7 kg meter to the minus 2 into second inverse, and from there you need to calculate the diffusion coefficient, this D value. So this is a normal procedure, just you put the value, put the value here. So J into D into X. So this is the question, so where you will get the value of this 0.63 into 0.668, so and this 0.25. so that is the difference between two different millimeter surface of this titanium slab. So you will get the difference delta C value, and now this is the calculation of this so 1 millimeter to 3 millimeter. So millimeter means 0.0003 meter, so this is the SI unit. So dcdx is the like concentration gradient with respect to the length, and you are getting the volume minus 214 kg meter to the power minus 4, and from there you can calculate the diffusion coefficient D equal to 1.24 into 10 to the minus 9 by 215. So you, which is giving the diffusion coefficient 5.906 into 10 to the power minus 12. So this is the so basically the answer is the so first is the answer, A is the answer. So what is the concept behind that? So if there is a difference in the concentration, difference in the concentration. So concentration is kg per meter cube with respect to the distance. So you need to calculate the ratio between the concentration difference as well as the distance, and from there you will get the value dc dx. and this is the base formula where j equal to minus d into dc dx. From there you can calculate the value of d. Now this, sorry. Now if they give the length, let's say here it is 1 millimeter to 3 millimeter. Now if they increase the length, that means this dx is basically increasing, as a result of which you will get the j value less. Okay, so here you need to be very careful that if you increase the value of this dx, then your j will be decreased. Okay, so and this is the 1.27 kg per meter square per second. Okay, this is the value for this rate at which the carbon is entering into its surface. Now this is a very simple, so here you need to basically get why is the negative sign introduced in the equation of Fourier's law of heat conduction, because the heat transfer is inversely proportional to a temperature gradient, and sometimes because the value of thermal conductivity is negative because the heat is transferred from higher to lower temperature. That's true, and it's none of the above, which is the negative sign introduced in the Fourier transfer law. So obviously the due to different due to difference in the this temperature, so your value will be the same. Now this is one of the interesting where you have to calculate the thermal conductivity value with the average velocity v and mean free path lambda is. So you have to calculate the relation between them. So you know that j2 is equal to minus k into del t del z from Fourier's law. Yes, Fourier's law, and k is the coefficient of thermal conductivity. Yes, so j2 you can calculate the j2 to equal to minus 13 v is the kind of velocity. Okay, average velocity n lambda into 1 by na into c bar cross. So this is the average value. So from there you can say that k is equal to this value. So this k, so you can put this j2 minus k into del t jlz at the place of j2 jt, and you can get the value of k equal to average velocity into lambda into n star into cv star by cv prime by cv bar by 3 na. Na is the Avogadro number. So your answer will be, so your answer will be n into cv. So there will be no negative sign, so out of them, so it will be, so between these two in be, so d is the answer here. So here answer is d, so the d is your answer. if you recall, so first we have calculated the diffusion coefficient, and followed by we have calculated that value of coefficient of thermal conductivity with average velocity, and this is the mean free path lambda, and lambda is basically correlated to this value thermal coefficient k equal to your average velocity lambda n cv prime cv bar by 3 na. So this is the Avogadro number. Now, so we have come across these points. Now you came to the another questions where you need to find out the viscosity of coefficient in accordance with Newton's law of viscosity. So it equal to 1 by third. So this is the average velocity into lambda into rho. So from Newton's law of viscosity. Oh, okay. So this is directly you can say that. So your first will be the answer 1 by 3. So basically 0.33 value into your average velocity into lambda into rho is the density, okay, density of the liquid, like Newton's the not liquid but the substance you are considering. So here question A will be the answer. Now you have the two molecules A and B, and they have given the diameter. Now you have to find that the correct relation between the viscosity coefficient of viscosity and between them. And we have already mentioned, I have already told that this eta equal to 1 by third this average velocity into lambda into rho, where lambda is the, what is lambda? Lambda is the mean free path and rho is the density. So now just this lambda equal to 1 by root t pi d square into n into v. So this n into v is the per volume, the number of molecules. So this is the diameter. So if your diameter is more, then your lambda will be less. If diameter is less, lambda will be more. So eta proportional to lambda, right? Lambda proportional to 1 by d square. So eta proportional to 1 by d square, right? So d is more means eta is less, right? So d is more means eta is less. Eta is more. So eta b greater than eta a. So your answer will be B, not the first one. Answer will be B. Which of the following relations is correct for the coefficient of thermal conductivity. So I have already with this k equal to minus average velocity and CV, and so this is the average velocity and CV is the value. Now 3 root by pi d square into Na. So d is nothing but this called the diameter. Now this k is the thermal coefficient. So in the previous case you know about this thermal coefficient value. This thermal coefficient is, sorry, it is a diffusion coefficient. This is the thermal coefficient of thermal conductivity. So k equal to 1 by 3 this average velocity into lambda into CV bar by 3 Na. So here also the same case where you need to get the value of this k thermal coefficient value, which is proportional to 1 by root over m, because your average velocity is also root over 8 kbt by pi, and this is the average velocity. Now you know this urms root over 3rt, and this C most probably root over 2 RT by m. So in all cases, if your mass is more, your velocity is less, right? So if you're a bulky fatty boy, so you will run less speed compared to the other compared to thinner boy. So similar kind of like analogy. So if your mass is more, then thermal coefficient will be less. If your mass is less, thermal coefficient will be more. So as the helium and argon, so as you know, this hydrogen helium, lithium, beryllium, boron, carbon. So these are the periodic table series, and helium is helium neo yes, helium, neon, argon, krypton, xenon, right? So helium has lower mass than compared to krypton. So helium will always, thermal coefficient of helium will be more than argon, right? So between these two we have to stick together, right? So and then nitrogen and argon, if you see, argon has the higher than nitrogen, so higher means lower value, right? So this Kn2 greater than Kr, like argon, for argon. So your basically the correct answer will be B. So mass is more means it has less average velocity, as a result of which your thermal coefficient will be also less. So these are the things one should take care of during this examination also. Let's say here not helium argon, now they are giving, let's say, xenon and radon. So for xenon and radon, obviously radon is a radon is a this radioactive active, so this compare may not be done. Let's say you have been given oxygen, and yes, let's say you have been given oxygen 16 and oxygen 17. So oxygen is 16 and oxygen is 17. This is a one pair of oxygen molecule, and now you have oxygen 17 17, oxygen 16 17. So where you will have the lowest thermal coefficient? Obviously if it is 17 17, their mass is more, so as a result of which you will get the less average velocity, and less average velocity basically will give you the less thermal coefficient value. Now in most of the cases you have seen that you need to calculate only thermal coefficient or diffusion coefficient. Okay, now if you need to calculate the speed, where you should calculate the value of this, like number of molecules very close to 300 meter per second to the number of speed very close to 100 meter per second. Okay, so this is the problem. So how we will approach this problem? So to approach this problem, you need to know the concept called the fraction of this molecules, right? So 4 by root over pi into m by 2 kbt to the power 3 by 2. So both denominator and numerator are same, only the velocity is different. So if you see that 300 and 100 meters square and 100 square, right? So 9 into 10 to the power 2 means 10 to the power 4. Here also 10 to the power 4, that will be divided, so you will get overall 9 beside the exponential term here. In the exponential, within exponential, you will get the you need to get the mass. So mass is 4.65 into 10 to the power minus 26 kg, right? If you multiply it is kg, right? So from there, so e to the power minus x by e to the power minus y, so e to the power minus x plus y, right? E to the power minus x minus minus plus, right? So this is a square minus b square formula, right? A square minus b square, a plus b into a minus b. So they did not use this one, so they directly calculated the value of this 10 to the power minus 6 into 80 into, because a plus b into a minus b, so 400 into 200, 400 into 200, right? So 80 into 10 to the power 3, right? So and at the below you will get the value, this 282 into minus 23. So here is 23 gone, minus 23. Now we have this 4.65 into 80 by 828. So if you do this, let me calculate with you as well. 80 into 4.65 bhajitak 828, right? So 0.0 yes, 0.4493, right? 0.449. So this is the value where you can calculate this t 300 meter per second. So you will get the value of this fraction of molecules which has a very close speed to 300 meters per second, to the number of speed very close to 100 meter per second. So this is one of the interesting example where you can see, you can see that you need to implement your knowledge in all the directions. Please let me know if you have any question. Now in the next few times we will go to another questions. So here is the another question, sorry, yeah, here is another question. So you have a fixed dimension of a wall wall means obviously this is a 2D, so you have the length, you will have the, yes, will have the length and width both. And what will be the rate of heat loss if the wall is insulated with fiberglass and the thickness of insulation is 30 centimeter. So, and the temperature difference on the two sides is this value del T del Z. So you know what is del T is del T del Z. So flux of energy equal to minus K to del T del Z. Del T del Z is already given because 10 by you have this diameter, like 10 by you have the value 30 centimeter, right? So 0.3 meter, yes, 0.3 meter. So from there you will get the gradient of your temperature gradient with respect to the width, and that is minus 10K by 0.3 m, and minus sign means indicates means width from the source. If you increase the distance of this other side of wall, so you will have the less value of this flux of energy, right? So basically flux of energy decreases from the starting point to the ending point, so that's why negative sign is there. Now total heat loss is nothing but area into J2, right? So area into J2, area is what we know, this 8 meter is the 11 meter is the length and 8 is the east width, right? So meter into meter, so both are in so 88, right? 88 meters square, that is in SI unit. Now J2 you need to calculate. J2 is what? Minus 9.2, because they have already given the coefficient of thermal conductivity is 9.2 into 10 to the power minus 2 watt into meter per Kelvin, which is also a SI unit, right? So this is the value of J2, where T in 3.06 is watt into watt per meter square. So from there you can easily calculate the total heat loss means area into J2. Area you know already 88 meter square, 3.06 is watt into watt per meter square. So both meter square into meter to the power minus 2 per meter square is already cancelled. So if you multiply that, you are getting 269.86 watt, right? 269.86 watt. So your answer will be around 270. Now this is the another example where you need to calculate the viscosity of coefficient viscosity for nitrogen gas having a diameter of 400 picometer at 29 Kelvin and 29 Kelvin. So 1 Pascal into second equal to, this Pascal is what? Pressure, right? This pressure into second. Pressure is what? The force like a mass per unit area. Yes, force is what? Force is pressure, right? Pressure is the, okay, pressure is the force per unit area, right? So unit area is meter square, force is, so per meter square means you need to do meter by meter square, overall it will be minus 1. So D is, so D has the value, D has, so D has the value around, so average velocity has the value around, so if you see this, so average velocity has the value around root over 8 kt by pi m, and m is known as 28 because you have the mass of nitrogen 28, 14 into 2, and as a result of which after strong calculation you can see that you are getting this C average around C average around C average around 474.7 meter per second. So this is a C like average velocity. Now from the average velocity you can calculate also the d square, because d square formula is already previously given. So from there you can get the value of your eta. Eta is 474.7 meter per second into 28 kg by 3 root 2 into 3.14 into 6.022 into 10 to the power 23 into 10 to the power 3. So after this calculation you can get the value, the eta, that is the viscosity of coefficient is coming around 10.35 into 10 to the power minus 6 Pascal into second, right? So 10.35 into 10 to the power minus 6 Pascal into 7. So C is your answer. So these are the very small question one can do during this exam period also, periods also. Okay, so these are a very important and logistic questions. The logic is very clear and clear. So this is the third session, 12 to 25. So we have many other questions also, we will do step by step. So this is the very question how you need to implement all your knowledge about these values. This is also an important question where you need to basically calculate the heat transfer from the one we heat to cold state having temperature difference. So already delta T is there. So temperature gradient with respect to its like length, like 20 centimeter. So this is the very good question. So you have the 20k already given, right, by 20 centimeters. So from there you can calculate the flux of energy, right? So you know, if you know the flux of energy net, then you can calculate the energy transfer like energy loss. And it is coming 5.543 joule into joule into second inverse. So in most of the case you will have to calculate the diffusion coefficient as well as thermal coefficient, and sometimes you will have to calculate also this, you need to compare the viscosity coefficient of any substance, let's say gas or liquid something, and the viscosity depends on many factors, you know, this particle diameter as well as this what I will say, this average velocity, and again average velocity is inversely proportional to its square root of its mass. So many parameters are there related, so changing of one parameter can affect your value of this viscosity coefficient. So we have other questions also. If you have anything, please let me know. So most of the case, they in exam they used to ask this viscosity coefficient, and sometimes in CS and they used to give the let's say they are saying to compare what could be the possibility to be compare nitrogen 14 for yes, nitrogen 14 versus nitrogen 14 15 or nitrogen 15. If you know this, if there is an increase of one mass unit, means there is an increase of reduced mass, as a result of which this average velocity will be lost. So if you say that nitrogen 14 nitrogen 14 15, nitrogen 14 15 has less average velocity than compared to nitrogen 14 right, because the mass is more, one unit, right? So as a result of which its eta will be also more, higher value. If you have any question, please let me know. Otherwise, we'll go for the further next questions.